This is going to be Quiz 2 Study Guide. And the first thing that I need you to get in your notes is it's a theorem that we didn't cover this week, but you can handle it. And here's what the theorem says. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar. Two triangles, let's say formed, are similar to the original triangle and each other. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and each other. So here's what an altitude drawn to the hypotenuse of a right triangle looks like. You take a right triangle, altitude drawn to the hypotenuse of a right triangle. So if this is your right angle, it makes this side, let's call this ABC, it makes side AC the hypotenuse, correct? So altitude drawn to the hypotenuse is right here. It goes from a vertex to the hypotenuse. Altitudes always intersect at 90 degrees, so these are both 90. So you got this little triangle, you got a bigger triangle, and you got the big triangle. They are all similar to each other, which means all the corresponding sides are proportional. Okay? Now, one more rule here. We're going to call this point D. All right? This altitude, all right, BD is equal to the square root of AD times DC. The length of this altitude is equal to the square root of the product of the two pieces that it created. Okay? Everybody with me? That's the new information. That's it. So learn it. Memorize it.
Why is it square root?
It's just the rule. It all has to do with right triangles and the Pythagorean theorem, and a squared plus b squared equals c squared, which is a derivative of or a partner of the distance formula, and all of that involves square roots. So it's been simplified down to say that the altitude drawn to the hypotenuse of a right triangle is equal to, it's called the geometric mean of the two pieces it creates. Geometric mean of two numbers is the square root of the product of the two numbers. Got it? Okay, so now, here's your notes for your quiz. And I'm just going to number them for you. We'll make it nice and easy. So here's example number 1. You're going to get a picture that looks something like these. And let's see. This is OKN and JM. and you've got a 6 and a 2 and a 36 and a 12. The question is, state whether the triangles are similar. If so, write a similarity statement and the postulate or theorem you used. So, do you see the little triangle, KOJ, and the big triangle, NOM? Those are the two triangles we're talking about. So you need to set up a proportion and see if the proportion is true. But you got to be careful here, all right? Because this is a little bit different than mid-segment. So we're going to set up a proportion of small side to big side. Got it? So our small to big is going to be equal to, the left side of the small triangle is 6. The left side of the big triangle is 8. So 6 to 8, does that, 6 to 8. Does that equal 36 to, we need the big side up top, which is 48. Okay? So does 6/8 equal 36 over 48? I'm going to tell you it does, because 6 times 6 is 36, and 8 times 6 is 48. Agreed? So you don't really need to cross multiply that, do you? So they're proportional. So are the triangles similar? Yes. Write a similarity statement. I'm going to call the first triangle KOJ. KOJ is similar to. If we called the first one KOJ, don't we got to call the second one NOM? All right, similar to NOM. And it says to say why, or state the theorem or postulate, and we're going to say by. Look what we used. Didn't we use side, angle, side?
Yeah.
Because they both share angle O. So we used side, angle, side. Number 2. What are the values? Okay, so we need a right triangle. All right, here's our altitude drawn to the hypotenuse. We got A here and B here, and we got 32 and 2. So isn't A equal to the square root of 32 times 2? So A is equal to the square root of 64. So A equals 8. Everybody good with that? Now, there's two ways you can find B. If A is equal to 8, and this is a right triangle, can't you do A squared plus B squared equals C squared to find the hypotenuse? Pythagorean theorem. The other thing you can do is use the rule about similar triangles. All of these triangles are similar to each other. All right, we just said that. So look, do you see this hypotenuse of the big triangle? What's its length? 34, good. All right, and we're looking for the hypotenuse of this little triangle, aren't we? Do we have two pieces of information about the big triangle? We need a hypotenuse, and I'm using Pythagorean theorem. You guys all right with that?
Yes.
Okay, I'm going to say that to find this hypotenuse, all right, 8 squared plus 2 squared equals, I know it's already labeled B, and C is normally the hypotenuse, but I'm just going to call it B squared. So 64 plus 4 equals b squared. So 68 equals b squared. So if you square root both sides, then the square root of 68 is equal to b. And the calculators that I have that do square roots have all been stolen. So 8.2. Alright. So there's your value of b for this problem, 8.2. And here's your value of a for that problem. Problem number 3 is just a right triangle with altitude drawn to the hypotenuse. The pieces are on the left 9 and on the right 26. And you are asked to find the length of the altitude drawn to the hypotenuse. It's this segment right here. So again, your x is going to be equal to the square root of 9 times 26. So x equals the square root of 234. And x equals, square root of 234 is 15.2 what? 15.3? Alright, 15.3. If you're not told what to round to, just round to the nearest tenth. Okay? Round to the nearest tenth unless the question tells you different. Okay, number 4. Same type problem, but it's in a little bit of a real life example. You got a big right triangle with an altitude drawn to the hypotenuse. Top left is a park. Top right is home. Home. And this other point of intersection is the library. Down on the bottom is the football field. Home to library is 2 miles. Library to football field is 7 miles. Question A is library to football field. Question B is park to football field. How far is the library? No, check that first one, I'm sorry. It's not library to football field, it's library. How far is library from park? So it's library to park. Sorry about that. Alright, so our library to park. Right here. Library to the park, x equals square root 2 times 7, doesn't it? So your x is equal to the square root of 14, 3.7. Okay? There's your library to park, 3.7. So now, we're going to take our library to the park, which is 3.7, and we're going to do the Pythagorean theorem to find park to football field. Okay? This is the hypotenuse of a right triangle. We're going to call it C this time. So 3.7 squared plus 7 squared equals C squared. The 3.7 squared is equal to 14 because the square root of 14 we use 3.7. So we got 14 plus 49 equals C squared. And 14 plus 49 is 63 equals C squared. And then we're going to divide both sides by No, we're going to square root both sides. So the square root of 63 is 7.9. Alright, so the distance from the park to the football field is 7.9. Number 5. We got A, P, Q, B, and C. AP is 7, AQ is X, P to B is 21, and Q to C is 12. And you are told that P to Q is parallel to BC. PQ is parallel to BC. So the segments created are proportional, aren't they? Alright, so our 7 over 21 has to be equal to x over 12. Crisscross multiply, so 21x equals, is 7 times 12, that's 84, divided by 21, x equals 4. Number 6. Number 6, you're going to get a picture of a road which goes across the top and another road that goes down here along the bottom. You got 4 plots of land, and the property lines of all these plots are parallel to each other. You're told that this is 40 yards and this is 48 yards. You're told that this plot 3 is 64 yards on the bottom. Alright? This up here on the top is called Cheshire Road. The question is, what is the length of plot 3 along Cheshire Road? So you're looking for this distance, agreed? So we'll call it x. If all of these plot lines or boundary lines are parallel, then aren't all the distances between them proportional? Okay. So our ratio is 40 over 48 equals x over 64. So 48x equals 2560, and divide by 48, and x equals, it's 53.3?
Yes.
53.4. Is that what you said, Brandon? What did you say?
Oh, well, I was thinking that if you did the, see, 48 minus the, or 48 minus 4 is going to be 8, so then you do 64 minus 8, so that's not like just
You got to do proportion, and when you're dealing with proportions, it's multiplication and division. All right. What was that? 50 what?
53 and 1/3.
53 and a third. Okay, so 53.3. Number 7. You've got a triangle with an angle bisector. This side right here is x and a 5.3, and then a 6.7, and it pairs with a 19.7. Find the value of x to the nearest tenth. Okay, so look, this is an angle bisector. So take the piece that it created, 5.3, put it over the side nearest to it, which is x, equals. We did piece over side, piece created over nearest side, right? Piece created over nearest side equals piece created over nearest side. So crisscross multiply, and 6.7x equals, somebody help me on the 5.3 times 19.7. And then we're dividing by 6.7. 15.58 to the nearest tenth is 15.6. X equals 15.6. Number 8. Number 8 is all words. Okay? I'm going to read it to you. An angle bisector of a triangle. So draw a triangle. An angle bisector of a triangle. So put an angle bisector in it. An angle bisector of a triangle divides the opposite side of the triangle into segments 7 and 5. So there's a picture of the words so far. A second side of the triangle is 4.5. A second side of the triangle is 4.5. Find the longest and shortest possible lengths of the third side. What they're saying is that one of these sides is 4.5. Agreed? But you don't know which one. So you need to find the longest and shortest possible lengths of the third side. So what you do is you put the 4.5 wherever you want to start with, and you call the other side x. All right? And you find the length of that third side. So you do 5 over x equals 7 over 4.5. So your 7x equals 22.5? Yes. 22.5, and you divide by 7. X equals 3 point what? 3.21. All right, and we're going to the nearest tenth. So we got a 3.2. Agreed? Now, we don't know if that's the longest or shortest, do we? So here's what you do. You just do the problem again, and you put the 4.5 at the other spot. And you put, I don't know, make this y if you want. Okay? So we get rid of these numbers. We already used them. Don't need them anymore. And now we're going to write the proportion 5 over 4.5 equals 7 over y. Crisscross multiply, so 5y equals 31.5? Anybody do it yet? All right, and then divide by 5. 6.3. So there's your longest and shortest possible sides for the third side of the triangle. Okay, you got 2 mid-segment problems that we're going to finish up on. Number 9. And let's see, number 9. You've got a triangle that they're going to give you. Looks like this. You get this picture. Remember we said yesterday that if a segment connects the midpoints of 2 sides of a triangle, it's called a midsegment. And the rule was that the midsegment is parallel to the side, the third side. And what else? Parallel to the third side.
And
Half of its length. So doesn't 2x minus 2 equal 10? So add 2. 2x equals 12 and divide by 2. X equals 6. Good? All right, and number 10. All right, B is the midpoint of AC. D is the midpoint of CE. Solve for x given that BD is 3x plus 4. And AE is 5x plus 13. Now, yesterday we said that the midpoint, or the mid segment, is half of the side it's parallel to, right? So we got to multiply, in this case, multiply the 3x plus 4 times 2 to make it equal to the 5x plus 13? All right, so we said this, that 2 times 3x plus 4 equals the 5x plus 13. So don't forget about your distributive property.
Wait, how do you get the 2?
2 of these equal this. Because it's half, right? It's half the length. So we got 6x plus 8 equals 5x plus 13. So our x plus 8 equals 13. Subtract 8. X equals 5. That concludes your notes for study guide number 2.